Hey everybody, today we're going to look at an algebra topic, simplifying radical expressions. So there's a couple different ways you can teach this. This is the way that I like to teach my algebra students. If you are trying to simplify a square root, you're going to take your number, you're going to break it into prime numbers. We call this prime factorization. So break it into prime numbers and look for pairs. All right, and then I'm going to come back in a little bit. That should probably have an S on it. And in the next video, we're going to talk about cube roots. But for now, we're going to concentrate on the square roots. So if we look at the first two examples, these are square roots that we know. We know that the square root of 25 is 5. And we know that because if we take 5 and square it, we get back 25. And we know that the square root of 49 is 7. But I want you to think about it another way. If I take 25 and break it into factors, that's going to be 5 times 5. And if I take 49 and break it down, I get 7 times 7. So notice anytime I get a pair, I can bring that number out, and that number is going to be my solution. Now that's not very helpful for the first two, but it is helpful for number 3. I don't know the square root of 84, so I want to break it down. Now we can use the tree method, kind of like I did on 1 and 2. I also like to use what's called the prime divisor method, which kind of looks like upside down division. I know that 84 is divisible by 2, and that's going to give me 42. And then that's divisible by 2, which is going to give me 21. Now each time I do this, the number on the outside has to be a prime. So I don't want to do something like 4 or 8 or 12. I have to do prime numbers. Alright, so I keep going until I get down to all primes. So what that tells me is that the square root of 84 is really the square root of 2 times 2 times 3 times 7. So now what I do is I look for pairs. Anything that pairs, I can take one of those out. So if you think about 2 times 2, that's 4, and the square root of 4 is 2. So I can take the 2 out, and then anything that doesn't pair stays in. Sorry, let me go back and erase. I erased it all. Let me try that again. All right, so the 2 comes out, the 3 times 7 stays in, so that gives me 2 square roots of 21. All right, so let's try the same thing with 125. If I break it down, it ends in a 5, so I know it's divisible by 5. Comes out to be 5 times 25, and 25 is 5 times 5. So the square root of 125 is really the square root of 5 times 5 times 5. So I look for pairs. Here's a pair of 5s. I know I can bring a 5 out. And then the leftover 5 stays in. So this one stays in. And I get 5 square roots of 5. Alright, so let's try 50. If I break 50 down, I can do 2 times 25, and then 25 is 5 times 5. So I get 2 times 5 times 5. Looking for my pair. That's what I take out. So the 5 comes out. Remember, it's just 1 5 because I'm taking the square root of 5 times 5, which is the square root of 25, which is just 5. All right, so the 5 comes out, the leftover 2 stays in. All right, so let's try square root of 120. It's a slightly bigger number. I'm going to have more factors there. So I could do 2 times 60, and then 2 times 30, and then 2 times 15. And then 15 would be 3 times 5. All right, so let's put all those numbers under there. I've got 2 times 2 times 2 times 3 times 5. So I go through and I try to find my pairs. All I have is a pair of 2's. So the 2 comes out. Now everything else stays in. I want to multiply it back together, so that would be 6 times 5. That would give me 30. Now what's kind of nice about this method is that it works with variables as well. So if I look at number 7, I want to break down 98 first. That is divisible by 2. So it's 2 times 49, and then 49 is 7 times 7. So whenever I break this one down, I want to go 2 times 7 times 7 times x, but then I want to write my y squared as y times y. So then when I start looking for pairs, not only do I have a pair of 7's, I also have a pair of y's. So I'm going to bring out a 7, and I'm going to bring out a y. So I get 7y on the outside. Anything that didn't pair stays in, so 2x on the inside. So 7y times the square root of 2x. All right, so we've got 2 more square roots before we move on to cube roots. So let's go up to number 8. If I want to break down 24, that would be 2 times 12. 12 would be 2 times 6. 6 would be 2 times 3. All right, so 2 times 2 times 2 times 3. X squared becomes x times x. Y cubed is y times y times y. So still looking for pairs. There's a pair of 2's. There's a pair of x's. There's a pair of y's. All of those come out. So I will take out a 2, an x, and a y. And if we look at what's left, I have 2 times 3 times y, and that will give me 6y. Now let's think about 81. Now 81 happens to be a perfect square, but let's just say you didn't notice that it was a perfect square. You can still use the other method. If I start breaking this down, it's 3 times 27, which is 3 times 9, which is 3 times 3. So when I break everything down, I get 3 times 3 times 3 times 3, x times x, and then it looks like y to the 4th, so 4 y's. All right, so when I go to look for my pairs, this one's kind of interesting because everything is going to pair up. All right, so I'm going to take out a 3, an x, a y, and a y. So notice when I do that, I don't have anything left over. So if I don't have anything left over, that means I don't have a radical sign left. So I would just put those together, and I would get 9xy squared. And that would be my simplified answer. All right, we will do the cube roots on the next video.